For years, sci-fi movies set in outer space have exposed us to thunderous explosions and the sounds of blasts traveling across vast distances. But does an explosion in space actually make a sound? And if it does, how far can it travel? Today, we're going to dive deep into these questions and answer them once and for all. But before we get into it, make sure to like this video, subscribe to my channel to support me, and leave a comment down below with your ideas for future videos. To start off, the question of whether the universe is completely silent actually goes back a very long time. That's because the human mind is naturally wired, or has evolved, to be in a constant state of curiosity. The origin of this question is deeply intertwined with another one. Is the vacuum of space truly empty? At first glance, the answer seems pretty straightforward. Based on our everyday experiences, sound requires a medium to travel through. In short, no air, no sound. Therefore, looking at the cosmos, it's easy to assume that because there is no atmosphere, space must be completely silent. However, as science advanced, the answer turned out to be far more complex than we initially thought. Physically speaking, sound is a mechanical wave. This means it requires a medium, a place where atoms or molecules can vibrate in order to propagate. On Earth, air provides these conditions. Whether it's an explosion, a collision, or simply someone speaking, what we are actually doing is vibrating the surrounding air molecules. These vibrations travel as waves, and when they reach our eardrums, our brains interpret them as sound. But in space, specifically in the interstellar medium, these molecules are incredibly sparse. In fact, they are so scattered that in a single cubic centimeter of space, you might find only a handful of atoms. Because of this, the propagation of conventional sound waves is virtually impossible. For many years, this led scientists to believe the universe was entirely silent. Experiments conducted in vacuums during the early 20th century definitively proved that sound cannot travel without a medium. So logically, those cinematic space explosions we see in movies are scientifically inaccurate. In reality, when a star explodes, a phenomenon known as a supernova, the energy released is mind-boggling. Yet we wouldn't hear it in the traditional sense. This brings us to a bit of a conceptual misunderstanding. The inability to hear something does not mean the sound itself doesn't exist. For instance, even on Earth, different species have different hearing ranges. Some creatures can perceive sounds that others cannot, but that doesn't mean the sound isn't there. Therefore, the universe isn't entirely silent. It just doesn't carry the kind of sound waves we are accustomed to. Subsequent research led scientists to uncover new revelations about space. The most crucial discovery was that space is not completely empty. Except for intergalactic voids, many regions are filled with ionized gas known as plasma. Even at low densities, this plasma can allow sound-like waves to propagate. For example, within galaxy clusters, especially in regions with massive gravitational fields, pressure waves can form. Technically, these fall under the category of sound waves, but their frequencies are so incredibly low that they are far outside the range of human hearing. One of the most striking examples of this was observed by scientists in the Perseus galaxy cluster. Observations made by NASA's Chandra X-ray Observatory revealed pressure waves rippling around the supermassive black hole at the center of this massive cluster. Scientists identified these ripples as the lowest pitch sound ever detected in the universe. Its frequency is so low that it rests billions of times deeper than the lowest note human ears can physically detect. So technically, a sound exists, but it is completely inaccessible to us. This discovery dealt a massive blow to the old notion that the universe is entirely silent. We now know for certain that sound waves can indeed form in specific regions of space, even if they can't be heard by human ears or generate a traditional racket. What's even more fascinating is that a form of sound played a pivotal role at the very birth of our universe. Immediately after the Big Bang, as you know, the universe was unimaginably hot and dense. During this epoch, matter and energy existed as a dense plasma. This environment allowed pressure waves to form and ripple across the expanding cosmos. Scientists call these phenomena baryon acoustic oscillations. These oscillations are essentially massive-scale sound waves born in the early universe. Traces of these waves can still be seen today, most clearly in the cosmic map of how galaxies are distributed. In a way, the structure of the universe is a map sculpted by ancient cosmic sounds. This brings up a question that crosses many people's minds. If there is sound in space, why can't we hear it? The answer is twofold, rooted in both biology and physics. The human ear can only perceive a specific frequency range, roughly between 20 Hz and 20,000 Hz. Most waves generated in the cosmos fall well outside this window. Furthermore, the density of these waves in space is so low that they lack the physical force to vibrate our eardrums. However, in our modern era, thanks to advanced technology and accumulated knowledge, scientists have found ways to render these invisible silent waves audible. For instance, radio telescopes detect electromagnetic signals coming from space. While these signals aren't inherently sound, we can translate their frequencies into the human audible range. This process is called sonification. Sonification is a groundbreaking technique. Through it, signals from pulsars, black holes, and even planetary magnetic fields have been transformed into tracks we can actually listen to. For example, when radio waves from Jupiter's magnetic field are converted, they produce an eerie, chaotic sound. Similarly, signals from the accretion disk surrounding a black hole sound like a deep cosmic hum. At this point, we can confidently say that the universe is not silent. It just doesn't speak our language. Modern astrophysics treats the universe not just as a visual spectacle, but as a dynamic system alive with vibrations and waves. In fact, some advanced physics models suggest that vibration lies at the very core of reality. String theory proposes that the most fundamental building blocks of the universe are actually tiny vibrating strings. If this holds true, then at the most fundamental layer of existence there is vibration, and therefore a form of sound. Einstein's theory of general relativity beautifully supports this conceptual framework. As you know, relativity dictates that mass warps space-time, and these warpings can propagate outward as ripples. These are known as gravitational waves. First directly detected in 2015 by the LIGO Observatory, these waves were produced by the collision of two black holes. This event was quite literally a massive cosmic vibration. Using the technology I mentioned earlier, scientists converted these waves into an audio format. Although the output sounds like a faint chirp, that sound is the actual echo of a black hole merger that occurred billions of years ago. Now, since I've explained that the universe isn't entirely silent and that it's just our inability to hear it, you might be feeling a bit hopeful. You might wonder, will future technology allow astronauts to actually hear a cosmic collision while out on a spacewalk? Given everything we've discussed, you might expect a yes, but unfortunately, the answer is no. Astronauts will never hear an explosion in space in the traditional sense. The barrier here isn't a lack of advanced technology, it's a fundamental law of physics. Right now, astronauts aboard the International Space Station ISS can obviously hear sounds inside the station because there is air, but they cannot hear anything happening outside. If a massive collision or explosion were to occur just a few kilometers away from the ISS, they wouldn't hear a single thing. In fact, if it happened out of their line of sight, they wouldn't even notice it. However, thanks to certain systems in use today, astronauts can indirectly feel the sound of space. Notice that I didn't say hear, I said feel. Here's why. Vibration sensors mounted on the exterior hull of spacecraft can detect the impact of a collision or a micrometeorite. These vibrations travel through the physical structure of the ship, allowing astronauts inside to sometimes perceive them as a faint click or a thud. So, the sound doesn't travel through the vacuum of space, but is generated indirectly through the spacecraft itself. Currently, scientists are working on systems that can detect electromagnetic waves, plasma vibrations, and even gravitational waves in real time within the space environment. With these systems, an event occurring in space could be detected instantly, and the data could be immediately converted into audio frequencies. This means an astronaut working outside the station could hear a distant explosion in real time. In a way, humanity is turning reality into a simulation, because when you look at it, what that astronaut hears isn't a natural sound, it's data. The waves hit the sensors feed the computer, and the computer translates that data into an audible frequency for the astronaut. Recent breakthroughs in artificial intelligence are immensely helping scientists push the boundaries of this technology. And there you have it, my friends. Space is neither completely empty nor completely silent. It simply operates on frequencies outside our natural perception. But thanks to evolving technology, we can translate the cosmic symphony into our own tongue, adapting the universe's data to fit our senses. I hope you enjoyed this deep dive and found it fascinating. If you love content like this and want to support the channel, don't forget to subscribe, hit that like button, and share your thoughts in the comments below. See you in the next video. Take care of yourselves, and goodbye.